RoundTower Technologies, and thanks to the Tech Council for the great day today. And we are a sponsor for this room. As you go out, if you want to drop a business card, there's a raffle thing on our table back there to win an Echo Dot. Get a taste of Alexa that John Dick was mentioning in the last talk, and also a pair of tickets to a Pens game later in the season. So give that a try. Quick overview on RoundTower. We're a 10-year-old tech provider based out of Cincinnati, Ohio, cover the eastern U.S., and we've had explosive growth over the last 10 years, primarily because we're very focused on high technical talent as we dig through and work through solutions. So we're able to really develop excellent solutions for our customers. We're in data analytics as one slice of what we do, and our first speaker is actually our practice leader for data analytics. I'll introduce in a moment, so he'll cover what we do there. But we do data center infrastructure from storage, backup, servers, virtualization, basically the whole range of a customer's data center infrastructure needs. We also focus in on helping customers via assessment on through deployment. If they want to go to the cloud, have an application they want to take there, those types of things, as well as DevOps and helping a customer work through and shifting their application modality to go quicker into agile development and DevOps. So from an analytics standpoint, Patrick Toole heads up that practice, and Patrick will dig in a little bit to a couple of different solutions we have that are pretty unique that allow customers to go deeper with virtual intelligence-based analytics. So, Patrick.
Thank you.
Okay. Good afternoon. It's always tough being the one after lunch. Now, he said it before in the presentation. He said, yeah, always look at the first time. I just looked at the time and it said after lunch. So I'm not going to sing. I'm not a singer. That would not be good. All right, my name is Patrick Toole. I'm the practice manager for big data analytics at RoundTower. As Steve pointed out, I'm going to do a quick commercial. Otherwise, the speech would not have passed the marketing sensors I have back at the office. So I'm going to give you the quick one as fast as I can. So again, started a few years ago. It was original foundations were in the hardware. Trying to help customers in providing expert advice in data center maintenance. That's really where it started. Since that point in time, the founders really understood that we had to hire in a lot of different disciplines in order to expand the scope of what we're doing. And today, full service firm, everything across the board, DCI, converge, collaboration, mobility, automation, cloud security, and big data. So the major focus, though, hasn't really faltered, hasn't changed as to what RoundTower has been doing. Actually, what it focuses on its business outcomes, really trying to focus for the customer-centric piece of it. And so anytime that we start to expand in these particular practice areas, it's always to focus on business resolutions. And that's really important, and that's what I'm going to try and describe for you today, are some of those examples of how we've done that initiative. Obviously, as technologists, we inherently are distracted by the latest feature and such. Spec or whatever it is, and keep us off the business objectives. So the practices are going to try and deliver those particular values. So specifically in the big data practice, we're trying to get business results by interacting with the customers through agile management philosophy. So just really generally speaking here, the idea is taking a small, repeatable engagement and expanding upon it, right? So when we talk about agile development, we certainly understand what that means, right? Build a small product, see if it works, expand on it. Well, sort of engagements are the same type of thing. We want to make sure that we continue to expand and put those into practice and build them into bigger and bigger engagements. So it's been very important, very successful, and something we continue to do. So some of the highest profile projects are around dramatically reducing costs and driving business insights. And that's really what I'm going to be talking about today. So I actually have a couple of things we'll be talking about here. We're going to hopefully keep it in a simple light, which is that how it's changed dramatically and how analytics and how data science has changed dramatically over the past period of time. So call this inversion of business decision processes. So in the past 40 years, we've really seen a dramatic change. And I know it can pick a long enough timeline and anything can seem dramatic here. But ultimately, what we're talking about is it's how data has changed the business decision processes has been misunderstood, and how it actually affects the day-to-day operations can be even more muddled, is what it ends up being. So when we looked at how databases were initially utilized on the daily basis, it's had profound sort of changes on the speed and accuracy in which we can get information, right? Within a single generation, though, so within that past 25 years here, we can look at massive growth in the data. So you look at the internet users have grown 80-fold, right? Anything from 40 million to 3.2 billion users for the internet today. And while we understand the growth, the organizational impact that has and how we actually monetize that is only just being learned about today. So from a data-driven culture, we're seeing interdepartmental analytical groups actually being formed. So the data itself is becoming the intellectual property, not the process or the product. And most importantly, there's a major shift here, which is fact-based decisions in the corporate culture. So let's think about that for a minute. Fact-based decisions are actually driving the decisions. Now, it used to be that the business person within the past, with the 20 years of business industry was revered. They're the person you go to and you talk to. We're more likely to see people staying at the same role or the same position and growing within a company for 30 years, not 3 years. So growth in one's job really came from experience and patience, or from a lifelong journey of seeing many experiences in the same daily routine or the same industry. So with the onset of big data, we're actually seeing experiences slowly become democratized in the form of analytics and data science. It's a big shift here. Now, what I'll share with you today here are 2 examples of this inversion of business. And I only have 10 minutes left there. Steve took it over there. But what we have is I have 2 examples. I'll make it very quick. And it's sort of uncovering patterns in the medical field. And the second will be an example of trying to solve problems before they occur. Okay, so it's predictive. All right. Okay. So I had this interesting opportunity to work with a research hospital. And for those of you who aren't familiar with a research hospital, which I wasn't until I started going there, they're basically a hospital, but they also have scientists who are looking at the information in order to help find additional cures or methodologies that they can increase accuracy. Now, we happen to work with a group of scientists researching hypertension. And specifically, they were examining the accuracy of diagnosis for systemic high blood pressure. Okay. So generally speaking, what happens, right, when we're diagnosing anything? Well, physician suspects you have hypertension, right? They do a bunch of tests. They look at the tests, and they say, sure, here it is. You have hypertension, right? That's what we think has to happen. Well, the trick here is how they're going to predict if the patient has hypertension or systemic high blood pressure. So like most people out there, I thought it was a bit more cut and dry, let's say it that way. Apparently it's not. So the accuracy of the prediction is only about 62% accurate. I'm going to pause there for a minute and think about it. 62% accuracy, okay? That means 38% of the people, right, are diagnosed incorrectly. Okay, now of course, if you're diagnosed and you don't actually have hypertension, you're going to have a big sigh of relief. But at the end of the day, there are people who were diagnosed as not having hypertension, and they actually do. So that's a big problem. So what actually happened here was the scientists at the research hospital compiled over 800 cases of diagnosis, both positive and negative, mind you, in order to create a formula to help physicians get a better idea of how to make the final decision, right, the final diagnosis. So they're using a formula based on tests that were done. Okay, so to help advance the predictive process was not as simple as dropping data into your favorite database, though. Okay? We had to be careful of a couple of aspects. First aspect is a technical one. How good is that data, right? The data is not clean at all. Some physicians don't request specific tests. Sometimes it's humans actually measuring blood pressure. And other times you might have informational problems. Believe it or not, even inside of a single hospital, you have cross-functional problems. In other words, one department has a set of records, and another department has another set of records, and they don't share with one another. So believe it or not, even inside of a single hospital, you can have the ability to see certain specific pieces of data and not be able to see those pieces of data. And then as for the human process, coming up with the answer doesn't necessarily mean it would, one, be trusted, or two, actually be adopted and put in place. So the key of getting adoption of physicians was obviously bringing them earlier into the process to examine the process by which you come up with the answers and use the data science for it. It's very important that we ended up doing that. Now, as a result, we actually saw a massive increase in accuracy. So while the sample size was small, what was actually difficult about this particular scenario was we had over 100 different variables: tests, blood pressure, height, weight, all of that. The new model jumped 23% in accuracy. That means the final accuracy model went to 85%, so only 15% likelihood of a misdiagnosis. Now, the remaining 15% we believe has more to do with data, but of course the modeling isn't always 100% accurate. Now, this particular study proved two distinct business objectives in data science that can accomplish, right? The first is accuracy. We all like the accuracy. We want to be diagnosed correctly, right? But the second here is that we were unable to uncover a threshold in the data. What does that mean? So what we found out was that there was something in the data called a threshold in something called fructose biophosphate aldolase B. There won't be a test later, so don't worry about that. If you're like me, you have no idea what it means. I'm not a physician. I know there were some doctors here earlier, so if I'm wrong, I'm wrong. But what we found out was that below a particular threshold, it had a massive impact. Above a particular threshold, it meant nothing. So there was this aha moment that the researchers had. And it was basically understanding that they were unable to see a pattern in the data, both as humans and as traditional data science techniques, in order to uncover that. And that's very profound when it comes to being able to do these kind of diagnoses. Now, as a general process, when we start talking about how do we finish this and how do we apply it across different industries or something of that nature, it's actually particularly interesting. Say manufacturing. The same type of process where you're looking at sensor signals coming in and being able to understand where there are thresholds in nonlinear systems can actually cause failures down the line or cause defects in the final product when you're actually looking at how the manufacturing process works. And humans inherently are unable to see the distinction on thresholds, or traditional processes also have a hard time capturing as well. All right. So the second study, which will be very fast, unfortunately, is a little more common to big data. So predicting server failures. So predicting failures is complex for a number of reasons, mainly because of the time series analysis that's required to complete the task. So I went to an insurance company, and they had north of 1,000 servers, ranging from small databases all the way up to Hadoop clusters. So a huge range of types of servers that they end up using. Now imagine for a second, not just 1,000 clusters, but imagine just 100 of them. And imagine that you're collecting data on every one of those every second for 1,000 different variables. There's a lot of data. Not to mention just collecting the data is a problem, but understanding the signal in that is actually a huge, huge problem. There tends to be very few signal to noise ratio, meaning the amount of noise compared to the number of failures is extremely high. So it's very, very difficult to actually pull that information out. Now, originally what ends up happening is people put in thresholds. They sit there and they look at it and they say, hey, if a CPU is running for over 90% for more than 3 minutes, we're going to look at that and say there's a likelihood of failure. Okay, makes sense. Now, the problem is that those tend not to happen, and when they do happen, they tend to be investigative type of operations only. You have to go and investigate and see if it actually causes a failure. So before I quickly jump to the solution, explain how the data scientists look at this, right? So basically, when you look at data, and especially in a time series, you look at it in either a parametric or non-parametric way. So generally speaking, very quick, data scientists in the room, don't beat me up. Don't throw the cookies. Well, actually, yeah, you can throw those. But generally speaking, the parametric way of looking at things is to assume that there's a certain set of variables within the data that actually will, in fact, prove or create the rule. The non-parametric way of looking at data basically estimates the variance of everything and then continues to increase the signals until it's able to model the overall system. Now, what it all means when you come down and you start developing it is that if there isn't a clear parametric way of modeling something, the non-parametric way actually will model it, but it tends to be brittle when it comes to predictive capabilities. So that's where you enter into sort of these ensemble mechanisms here. So the way we solved it was actually to create an artificial threshold. It was to create an artificial threshold out of a parametric type of algorithm. And what ends up happening is when this threshold actually changes or is broken by more than one variable, then you're able to say it's going to fail in the next hour. So when we placed the signal detection into use, what we actually saw was the uptime of all the systems go from 99% to a 4.9 uptime. Now, keep in mind, the vast majority, believe it or not, wasn't so much that, hey, it correctly predicted it, but it was the ability to react to something and actually cause a backup to start prior to any failure happening. So the downtime actually went dramatically down. Okay, so how do we talk about bringing this all back together, and what does it mean in terms of the organizational behavior? We have to take from these types of projects, and many of us in the room are working on those types of projects, is that we undertake the analysis of big data. We are, in effect, changing how we run our businesses and being able to understand how we run the businesses. When we begin to trust the data over a person's intuition, we're inherently asking one another to show our work. That's the fact-based decision-making. We're already entering in a time when businesses are looking for proof that their decisions are, in fact, profitable for the business to make. That's why we have analytics. That's why we have data science. We all need to understand that the new analysis, scale, and insights will effectively allow industries to go further, deeper, and be more effective. And what we're embarking on a time when hyper insights will determine the success or failure of competitors. And those without the ability to take on these insights will, in fact, find themselves struggling to keep up. Thank you very much. Appreciate it.